In this video, we'll be exploring the topic of the final few weeks for the decedent population, considering care close to death, looking at terminal episode length of stay, possible non-beneficial chemotherapy treatment, and how critical care is used at end of life. I'll be talking through some of the key analysis from our report, using the Midlands as an example, but all this information is available by STP in the STP level reports, and these also show STP comparisons to the Midlands. This is the fourth video in a series taking a short look at key themes from our report on end-of-life care in the Midlands. The full report for individual STPs and also a regional version are available at www.strategyunitwm.nhs.uk. And if you have any comments or queries, please feel free to get in touch. Before we look at the analysis, I just want to really briefly mention the data that's underpinning all of our end-of-life care report. We have access to mortality data, which is the information that's collected when a person dies and their death is registered. And we know from this that there were just over 93,500 adult deaths in the Midlands in 2018-19. Obviously, 2018-19 is a period which predates COVID. Therefore, throughout all of our analysis, there is no effect from COVID, and this represents, therefore, a more normal or business as usual situation for end-of-life care services. Data is linked for each deceased individual to their activity data occurring in the 2 years prior to their death, where activity is available and also at a patient level. This gives a very granular patient level data set with a wealth of detail. This data is also available to your local analysts for them to access. If you would like us to arrange access to the data to help support any local or supplementary queries that you may have, please just contact us to arrange this. In one of our earlier videos, we've seen that 47% of decedents in the Midlands die in hospital, generally after being admitted as an emergency. But how long have decedents who die in a hospital bed been in that hospital bed? The chart here shows a proportion of all decedents by the length of stay of a terminal episode. So the first bar on the left shows 2.5% of all decedents in the Midlands die in hospital with a 1 day length of stay. This means that they were admitted to hospital and died the same day. The next bar, 2 day length of stay, so those admitted and then dying the next day, accounting for 5% of all decedents, and this is the single largest group. Generally, we can see terminal lengths of stay are short. Their distribution is heavily skewed to shorter lengths of stay, and the proportion with longer lengths tail off. We discussed in an earlier video the high proportion of deaths in hospital, and this further analysis shows that many deaths in hospital are of short duration. We're now moving on to consider a potential non-beneficial treatment, that of late chemotherapy. This was highlighted in research around non-beneficial treatments and also in a recent study which found that palliative chemotherapy was associated with worse quality of life and did not increase survival. To investigate this, we split decedents who have chemotherapy into two distinct groups. We have the earlier group who did not receive chemotherapy in their last 4 weeks of life, and we have the later group who did receive chemotherapy in their last 4 weeks. There are 14% of chemotherapy decedents in the later group and 86% in the earlier group. This chart shows the patterns of chemotherapy use for each of these two groups. The patterns between the two groups are very different. The earlier group are higher for most of the 2 years and peak nearly 7 months before death, at which point they decline slowly. By definition, this group have no chemotherapy 4 weeks before death. The later group are much lower for much of the 2 years. They start to increase more rapidly at the point the other group decline, around 7 months before death. And they continue to increase more rapidly, peaking close to death. So how else do these two groups differ? Well, from our report, we'll now look at how these two groups differ by start date of chemotherapy, by age and by cancer type. Investigating the two groups to see if late diagnosis was an issue, we looked for each chemotherapy decedent for when their first chemotherapy took place. We then plotted this on a cumulative basis. This shows that 12 months prior to death, half of the earlier group have received their first chemotherapy. For the later group, this figure is only 25%. At the point 4 weeks prior to death, 75% of the later group have received their first chemotherapy. This means that 25%, or a quarter of people in this group, are still to receive their first chemotherapy 4 weeks before they die. We know that overall 14% of chemotherapy decedents are in the later group. The overall proportion is represented by the dashed line on the chart here. However, the chart also shows the proportions in the later group, but by age. So 16% of 18 to 64-year-olds, the younger decedents, are in the later group. Calculating meaningful averages can be tricky. For example, if we have a very small sample, then it's difficult to be sure that an average value is truly representative. We therefore calculate confidence intervals, indicating the range in which we are confident the true value lies. As the range of the confidence interval for 18 to 64-year-olds is higher than the average for the whole group, then we can say with confidence that there are a significantly higher number of 18 to 64-year-olds in the later group. For those aged 65 to 74, there's no significant difference. And for older patients, both 75 to 84 and 85 and over, there are significantly fewer in the later group. And as we did with age, so we investigate proportions by type of cancer. This shows that there are significantly more in the later group with hematological, skin, metastatic disease, or pancreatic cancers. There are significantly fewer with either upper or lower gastrointestinal, urological, gynecological, brain, or prostate cancer. We now consider critical care for the decedent population. Critical care is a very expensive resource and was also highlighted in research around non-beneficial treatments. The chart here is showing the number of days spent in critical care by the decedent population. This type of chart is called a NICO chart, and it's quite similar to a stacked bar chart. It's similar in that it's got vertical stacked columns, but it differs in that the width of the columns also indicate scale. Here, we see that the largest proportion of critical care days, or the widest column, are for those dying from organ failure, and that most critical care days in this group, 88%, result from emergency care. Indeed, critical care days usually result from emergency care for most cause of death groups. Only cancer deaths are significantly different, with nearly half of critical care days as part of an elective admission. Critical care may also be a place in hospital in which people die. As part of our analysis of critical care at the end of life, here we have the proportion of deaths in critical care by cause of death group. The yellow dots indicate STP proportions and the grey dots the Midlands. Again, there are confidence intervals, and we can see that for this STP, there are no causes where the proportion of deaths in critical care differs significantly from the Midlands. We can also see that there are two distinct groups in terms of proportion of deaths in critical care. There are a low proportion of deaths in critical care for both cancer patients and those dying from frailty, whilst other terminal illness, sudden death and organ failure all have a higher proportion of deaths in critical care. Thank you for watching this video investigating the final few weeks of life. You can find the other videos in this series at www.strategyunitwm.nhs.uk. And again, if you'd like to get in touch, please contact us at strategy.unit@nhs.net.